Welcome to lesson 1.6. This is example 1. We're just talking about systems of equations here. So first thing, here's a system, right? Let's define a system of equations as a set of two or more equations using the same variables. It's always going to be the same amount of variables as there are equations. So if there's 3 variables, there would need to be 3 equations. The solution of a system of linear equations is a set of all ordered coordinates that simultaneously make the equations in the system true. So it's the values of x and y that work in both. A couple ways to solve. First would be if you graph both lines. Where they intersect, if they intersect, would be the solution. Graphing isn't always the best way to do it because it's kind of hard to tell exactly where it's intersecting if it's not right on a lattice point. So algebraically, you could solve this. Well, you can actually solve this a couple ways algebraically. First way to consider would be substitution. So if you just took both equations, solve them both for x, you could essentially substitute 3 minus 2y in for x in the blue equation. What you end up with is 3 minus 2y is equal to 4 plus 2y. You solve for y, you get negative 1/4. You substitute that into either of the other two equations and solve for x, and you get 7/2 for x. So then the solution is 7/2 and negative 1/4. So again, graphing works, but it's hard to be as precise. The other thing you could have done with this that they're not suggesting even in the notes here is by elimination. All right, so we'll demonstrate that on the next example. So why don't you try both of these and see how they go, and then check back for some solutions. All right, I would solve the first one with substitution because one of the variables doesn't have a coefficient. So what I'm going to do is I'm going to solve that equation for y by subtracting 2x from both sides. So I've got y is equal to negative 2x minus 1. That negative 2x minus 1 I'm going to substitute in for y in the other equation. So now I've got 5 times negative 2x minus 1 minus 6x, and that equals 7. Now I'm solving this for x, distribute the 5, so negative 10x minus 5 minus 6x equals 7. Combine the x's, you get negative 16x minus 5 is equal to 7. I'm going to add 5 to both sides. I get negative 16x is equal to 12. I divided negative 16 on both sides. I get x is equal to negative 12/16, which you can divide a 4 away. So you get x is equal to negative 3/4. All right, when I go and solve for the y, I'm going to substitute it in right here. So I've already solved for y. So I'm just going to substitute in the x, and the work is essentially done. So y is equal to negative 2 times negative 3/4 minus 1. Negative, well, all right, so that will cancel out there. The negatives actually would make it a positive. So it'd be 3/2 minus 1. Y would then equal 1/2. All right, so the ordered pair here would be negative 3/4, 1/2. Okay. For the next one, erase that now. For the next one, I would actually solve this with elimination. The reason being, there's no way to solve for one of the equations and solve for one of the variables in one of the equations and not have a fraction. And especially because it's already set up in both in standard form, that it's set up for elimination. So what you need to do though is figure out what you want to eliminate. First thing that jumps out to me is that 3 is half of 6. So if I multiply the first equation by -2, I'm going to create the x coordinate, the x being the opposite of that x. So I'm going to rewrite that down here. You have -6x. Again, -2 times 3x would be -6x. -2 times 2y would be -4y. And then -2 times 5 would be -10. Now I'm going to combine those equations. And what ends up happening is the x's eliminate and the y's also eliminate. So I was intending for the x's to eliminate. The y's also eliminated, meaning I have nothing on the left side of the equation. And then 3 minus or plus -10 is -7. That is a false statement. So that means there is no solution to this system. Okay. If you were to graph these, you would see that the lines are parallel and that they never touch. So where they intersect is normally the solution. Like for 1a, they would intersect at the ordered pair that we got. I forget what it was. It was like 3/4 and then -1/2, whatever. The two lines would intersect at the ordered pair that we got. Here, no solution means they're not intersecting at all. Okay. Let's try example 2.